The persistent object store, referred to hereafter as POS, is a key-value storage system designed for single-machine deployments requiring durable object serialization. This manual documents version 2.1.4. POS maintains objects in binary format on disk using sequential write operations. All objects are indexed by a 64-bit unsigned integer key. The storage backend utilizes a fixed block size of 4096 bytes throughout all operations. Object serialization occurs at the record level. Each record begins with a 16-byte header containing metadata. The first 8 bytes store the object key as a big-endian unsigned integer. The next 4 bytes contain the payload length in bytes. The remaining 4 bytes contain a CRC32 checksum of the payload. Payload data follows immediately after the header without padding or alignment constraints. The storage file is organized into sequential blocks. When a write operation is initiated, POS appends the record to the current active block. If the record size exceeds remaining block space, the current block is padded with 0 bytes and a new block is allocated. This ensures records never span multiple blocks. Block allocation occurs synchronously. The file descriptor remains open for the duration of process execution. The in-memory index is a sorted binary tree mapping object keys to block offsets. Index entries contain the key, the absolute byte position of the record, and the record length. Index construction occurs during process initialization. The entire storage file is scanned sequentially. Each record header is parsed and validated. Index entries are inserted in key order. The index is never persisted to disk and is rebuilt on each startup. Read operations query the in-memory index for the requested key. If the key exists, the stored block offset is retrieved. The file is seek to that position. The record header is read and validated. The CRC32 checksum is computed over the payload. If the computed checksum does not match the stored checksum, a verification error is returned. Otherwise, the payload is returned to the caller in its original binary form. Write operations require an object key and a binary payload. The payload is validated to ensure its length does not exceed 16,777,215 bytes, which is the maximum value for a 24-bit unsigned integer stored in the header. A new record is constructed with the key, payload length, and computed CRC32 checksum. The record is appended to the storage file. The in-memory index is updated or inserted accordingly. Deletion operations do not remove data from the storage file. Instead, a deletion marker record is appended. This marker consists of a record header with the target key and a payload length of 0. During index reconstruction, deletion markers are processed after all records. If a key has a deletion marker, it is removed from the index. This approach ensures write-only semantics to disk. Compaction is a maintenance operation that rewrites the storage file, removing fragmentation and deletion markers. The operation reads all valid records from the current file in index order. A new temporary file is created. All records are written sequentially to the temporary file. Upon completion, the temporary file is renamed to replace the original. Index reconstruction occurs subsequently. Fsync behavior is configurable through the sync policy parameter. The sync every option calls fsync after each write. The sync batch option batches writes and calls fsync after every 1024 records or every 30 seconds, whichever occurs first. The sync none option relies on operating system buffering. Default configuration is sync batch. Fsync calls block the writing thread until completion. Concurrent access is managed through reader-writer locking. Multiple readers may simultaneously access the index and read data. Write operations acquire an exclusive lock. During index reconstruction, all locks are held exclusively. Read locks have priority and do not starve. Lock acquisition timeout is configurable with a default value of 5 seconds. Lock timeout results in a timeout error returned to the caller. Recovery from corruption is limited to index reconstruction. If an object payload is corrupted, the CRC32 checksum verification will fail during read. The corrupted record remains in the storage file. Recovery options include deletion via deletion marker or exclusion from the index. No automatic repair mechanism exists. Manual intervention or external tools are required to remove corrupted records from disk. Storage file path is specified at initialization through the file path parameter. The file is opened with read-write access. If the file does not exist, it is created. If the file exists, the index is reconstructed from its contents. File permissions default to 0644. The directory containing the file must exist before initialization. Initialization failure results in an exception. Memory usage during index reconstruction is proportional to the number of unique keys in the storage file. Each index entry consumes approximately 32 bytes. The entire index is held in memory during operation. Index size can be estimated by multiplying the number of records by 32 bytes. No index compression or overflow to disk is implemented. Statistics are maintained for diagnostic purposes. The record count represents all records including deletion markers. The active record count excludes deletion markers. The total payload byte sums all payloads excluding headers. Storage file size includes all headers, payloads, and padding. Statistics are computed during index reconstruction and updated incrementally. Query operations do not block statistics updates. Configuration parameters are provided at initialization in an options structure. Cache size specifies the maximum in-memory payload cache in bytes. Default is 0, disabling caching. Max record size enforces a per-record limit in bytes. Default is 16,777,215. Block size sets the allocation granularity. Default is 4096. These parameters are immutable after initialization. Shutdown behavior flushes pending writes and closes the file descriptor. If sync policy is synced batch, a final fsync call is issued. The in-memory index is cleared. All locks are released. Subsequent operations fail with a not initialized error. Graceful shutdown is recommended. Abrupt termination may result in index reconstruction on next startup, which is safe and incurs no data loss.